Okay, so then they came up with these two ideas of like measuring complexity. So complexity together are this measurement of coupling and cohesion. Cohesion is sort of like how well the code inside one unit, and here a unit might be a file or a class or a method or a function. So like the size of the unit, the context of the unit could be different, but how well it sort of hangs together and is like one thing or serves one clear purpose. And then coupling is like how much a particular unit sort of like tugs on its neighbors when it changes. And so cohesion, think about some classes that you've written. Sometimes we end up with what's called a God class, where like it just accumulates functionality. And if you look at all the different bits of functionality, they're not really related, right? It should probably be split up. So that we would say that class has low cohesion. And then coupling, it's like you change something here and suddenly you're doing what's called shotgun surgery, right? Like you change something here and like you got to make changes throughout your code base, right? Because surgery with a shotgun is messy. Yeah.
I have a wonderful example.
Okay.
So I do a project with stacks and cubes, right?
Yeah.
And somehow I managed to connect a variable with another variable that didn't even exist anymore, and which broke the machine so much. Like it ran, but one simple thing was gone and still ran, and then nothing was. We don't even know. My friend looked over and like, where the
You're like, how is this even working?
Yeah.
Yeah.
I don't even know what happened to this day. I had to just completely quit that and just restart.
And sometimes that's the answer, right? Sometimes it is like the answer is like restarting. Yeah.
So you're pretty much kind of saying less dependency is better code.
Yes. So coupling is directly tied to dependencies, but it might even just be like this line of code is coupled to this line of code. Anytime I change this one needs to change. But it might be all the way to like, as you say, dependency. So like this particular class that I'm working with is coupled with this other class that I'm working with, where they almost like they know too much about each other's internal state, where if you change this one, you now have to change this one. So it can happen right down to like this variable is coupled with this one, or this line is coupled with this one, to like this, whole piece of software is coupled to another piece of software, because one is a client piece of software, and another one's a server piece of software, and they need to they're coupled by way of the client-server protocol. So there's also, and you can never completely get rid of coupling, because then none of your units of your code could communicate with each other. There has to be some coupling, but you want low coupling, and then you want high cohesion. So I finished reading a book the other day, which was really good, which sort of like inspired me to write some of these notes, which was called Tidy First by Kent Beck. And I'm just going to read, this is from the foreword where they're talking about coupling and cohesion. And so in the foreword they say, coupling and cohesion are simply measures of the complexity of computer code, not from the perspective of the computers executing the programs, but that of the human beings trying to understand the code. Because at the end of the day, the computer doesn't care how coupled your code is. The computer doesn't care how cohesive your classes are. It's just running binary numbers through a CPU, right? So all of this is just in relation to the humans trying to understand the code. And so they continue saying, to understand any program, whether to create it, or to correct it, or to change it, requires understanding the piece of code immediately in front of you, as well as those other pieces of code to which it is connected, right? So the piece of in front of you is going to either be cohesive and understandable or not, and it may be coupled to other pieces of code in the code base. And then, so it says those other pieces to which it is connected, which it depends on or affects or is affected by, right? Because the cohesion can go in, so there can be cohesion that's sort of two-way cohesion, there can be one-way cohesion, there can be reverse cohesion. And they continue on to say, it is easier to understand the immediate piece of code if it all hangs together. if it makes sense as a whole, if it forms what cognitive psychologists call a gestalt. That's cohesion. And it is also easier to understand in terms of its relationships with other pieces of code if these relationships are few and relatively weak or highly constrained. That's coupling. Coupling and cohesion are really all about how your brain deals with complicated systems. And so it's not even just code. We could talk about all sorts of things that humans have to understand in terms of coupling and cohesion. And so now that you have those bits of terminology, do you have experiences of thinking about or working with code where you felt like you maybe didn't have the word for it, but it felt like the cohesion was off, or that things were like overly coupled? Anyone have an example of that? Yeah.
Usually when you have like two games, or like in Unity, you would have some like script that is like a data collector and then something that needs the data.
Yeah.
There's not like easy way without connecting them directly with Unity events or just dragging it in.
Yes.
It kind of feels wrong, but it's needed.
It's needed because at the end of the day, the coupling is the only way to get those two systems to communicate, right? So, because otherwise you would have to put those two systems directly together, but then that might lead to lower cohesion, because even though they're related, they may not belong bundled together.
Just another question.
Yeah.
If you have a joining script in between them, like the glue, instead of like, so they're separated systems, but then you have like a glue thing that glues them together, would that be better or worse?
Often it can be better, and there's a lot of like architectural patterns that sort of act as that glue, because the glue can almost be a way of communicating the intent of how they are coupled, right? Because then someone can, instead of just like, because sometimes the coupling is like, even in Unity, where it's sort of stitched together through drop downs and whatnot, and it's like you're digging through the code looking for what drop down connects this. But if it was in code somewhere, it would spell out exactly, why these two things are connected, how these two things are connected, what data is being exchanged, how much they know about each other. So you can make something more explicitly coupled by having that kind of glue class. So yeah, definitely. Yep.
An example of this is when in one of my portfolio pieces, I made like a dev tool that allows you to like script out dialogue scenes through like a somewhat and then it results in like a very readable JSON format at the end. But the way that I did it was that you started with smaller UI elements that then feed in and then like organize all of the structure of the information as it goes up the chain.
Okay.
But that resulted in a situation where if I had to change anything about the base structure of it, I had to then propagate all of those changes through the entire
Yes.
chain of command, and it caused me several hours of work where I could have probably skipped if I had just made it more to the point.
Yeah. And object orientation often leads to this kind of coupling because we have like a base class that we are hoping gives us some power of shared functionality. But now we have coupled all the child classes together in this hierarchy. And so, a change to this child, even though it should be completely isolated with this one, it might start messing with some of the internals of the base class. And it could sort of result in changes sort of throughout the object-oriented hierarchy.
To that point, if the class you're designing, like, let's say it was entity, if it was meant to be very basic and level, wouldn't it be like the fault of the programmer almost? Like,
Yeah.
keep expanding where it was meant to be, and they should have shipped them to another hierarchy somewhere else.
It's often just like really tempting to feel like two things are related. Like sometimes we just shouldn't even make the hierarchy, right? It's like this thing feels like it's related to this thing. Maybe there's some kind of base class that relates them. And sometimes like we're stretching that a little too thin and we end up with a hierarchy that isn't serving us well, right? And another way that we can sort of like deal with that in a more structured way is that with every class we have this idea of some aspects are public, some aspects are private, and some are protected, right? And we should try to make as much of it as private as possible, because coupling often happens because you know too much and are relying on the internal state of the objects that you are interacting with. And then that also makes refactoring hard, because if I try to refactor my code, but someone else is relying on some of the public API or some of the public state that really shouldn't be public, then I can't change it anymore. And so that, like, even in a large organization, you release something, you make your public API too large, a whole bunch of people start relying on that, you're stuck with it. Yeah.
So quick question. Inheritance makes things more modular, right? Like using
Yeah.
interfaces in that. Is that more useful than if you couple it together? Or that like kind of as you go?
That's an as you go. So it's almost like every situation is you're gonna have to sort of vet sort of the trade-offs, because there's always trade-offs between like coupling and cohesion. Yeah, so that's the hard part about programming, is that there's never one right way to do any given thing. So again, just to recap, we have cohesion, which is like, is there one clear purpose? Or you can ask yourself, like, do all the elements of this unit belong together? And again, unit can be this file, this class, this like just this little method or this function. And we want high cohesion. We want there to be just one clear purpose where everything sort of hangs together nicely. The warning signs of low cohesion is that you have a unit that like mixes a whole bunch of different concerns together. So it's maybe like it's handling inputs, but it's also handling rendering, and it's also handling logging. It's just doing too much across a bunch of different domains. You just find yourself literally scrolling a lot to like find the other half of the logic. You're like, oh, the logic started up here, but where's the rest of it? And you're just scrolling and scrolling to find it. Or you just like, you're trying to explain to someone what the class does, or even to yourself, or to name it even, what this thing specifically is for, and that's hard to do, right? If you can't just say like what this one thing is specifically for, you probably have low cohesion in that thing. Coupling, we're trying to avoid that idea of shotgun surgery. We're trying to keep the ripples of our changes small. Again, we're often working with legacy code, and so when we make a change, we want that change to be targeted and not have a huge external effect. And so you're going to ask yourself, if I make a change to this unit of code, how many other places do I now have to go and edit? And some of this, thankfully, gets automated away for us, right? So some of it, the tooling that we now have in IDEs, will allow us, like we suddenly realize we want to add a new parameter to a method signature. In the past, we would have to find every caller of that method and add a new argument. Now we might be able to, with the IDE, say like this signature is changing, it'll find all of the callees and it'll allow us to update them. Not quite in one go, but it'll at least identify them and provide a way of stubbing in the argument that we can go deal with. And we want low coupling, but you can never get rid of coupling, right? Because again, then you would have a system where nothing can communicate with anything else. And so sources of high coupling, it's just like units of code that are really dependent on each other. And again, this might just be like line 12 is really highly dependent on line 14. Code that reaches deep into another object's internals, that's that idea of like, if you can make some state private, you should, because otherwise some part of the code is going to end up relying on it. And just in general, the caller knows too much about how something has been implemented, whether it's a class or a method. This idea of encapsulation or like hiding of complexity in programming is something like it's a power that's sort of overlooked. The more we can make it so that no one needs to care from the outside how a particular part of our code is implemented, and they can just use it as a tool, that's better than if they have to know the implementation details, because they might end up relying on those implementation details. All right, before I go any further, any other thoughts on just this idea of like measuring software complexity in terms of like looking at cohesion and coupling? Because I just want this to be like a tool that you can use when talking about your own code, or even gently talking about the code of your peers. You're working on a project with a peer, And you might notice that like the way that they have coded something is they skipped a few steps, and instead of like properly passing, you know, some data into a class, they're relying on some kind of global state. Or you could just see that like two of the classes are just like highly coupled. And you might gently point out to them, like, it seems like these two parts of your code are highly coupled, and you will have a sort of a shared language that you can now use to communicate that. Or you might look at their code and say, like, this looks like it should be, this class maybe needs to be broken out into like 3 other classes. There would be high cohesion if like these 3 things were grouped together, these 2 things were, and this one was separated off on its own. Yeah.
I was just wondering, I don't know if this would want that kind of question to be, but like inheritance, right? At the end of the day, it's like a final thing, I guess. Like after you made your base code, you would refactor it into an inheritance system to reduce the coupling and like modularity of it.
Yes, and like inheritance, like it's almost like when we think about object oriented, it's like it's the one tool everybody thinks that is like the most useful part of object orientation. And I actually think the most important part of object orientation is the encapsulation part, like the hiding of the implementation details. And so I try to step away from doing inheritance if I can.
Okay, so step away from that. And
It works in certain cases, like when you get into Unreal, and I'm sure you see it in Unity as well. There's like in Unreal, they have a beautiful pre-set up hierarchy of like, there is a base thing called an object. And on top of that, there are actors, and actors have transforms in the world. And on top of that, there are pawns, and a pawn is an actor. It inherits from actor, an actor inherits from object. And a pawn is like a possessable actor. It can be possessed by an AI or by a human controller. And then you have a character, which is like a bipedal with animation pawn. So it is a very nice sort of like system for inheritance. So it's not like we don't ever want to use inheritance, but we want to think twice about using it. Because sometimes it can lock us into like a bad pattern.
okay, when you say abstraction, what do you mean by that kind of?
Yeah, so abstraction is like anytime you can take something simple, give it a nice name, and hide, or take something complex, give it a nice name, and hide the complexity behind the abstraction.
Okay, so it'd be like just calling a method.
Yeah, calling a method or creating a class, like anytime you can sort of like take the implementation details that make something difficult to work with, and like work with that difficulty yourself, and then make it so that others are abstracted away from that, so others don't have to deal with that complexity anymore.
Do you usually want to hear that? They usually use inheritance and then extract from there, and then they can hide everything because everything's already built for you,
Yeah,
and then they inherit from that class.
and inheritance is like it is our big tool in object orientation for creating abstractions.
Okay, that's
Yeah,
what I was-
but even just writing a function on its own is an abstraction.
Okay, that's where I was confused what you're talking about, like inheritance and not being an abstraction.
Yeah, so it is an abstraction, it's a major tool for abstraction, but we have other tools as well.
Okay.
Yeah. Any other final thoughts on coupling and cohesion? Okay. Who knows what the word grok means? And not like the AI from X.com. Because that, I really wish they hadn't used that name. Yeah.
It comes from an old book called Stranger in a Strange Land, or yeah,
That's, yep, Robert Heinlein.
Yep, what a guy. And it just means that you thoroughly understand something like to its deepest core, basically.
Yes, and so like it does come from Stranger in a Strange Land. I'll read this quote from it. It was like taken, the reason I bring it up is that after this book came out, sort of the hacker community / programming community sort of like latched onto this word. And so this quote from the science fiction novel, which is about a Martian who comes to the planet Earth. And one of the words that they have in the Martian language is grok. And grok means to understand, of course, but it also means to drink, and 100 other English words that we think of as antithetical concepts. Thank you. Grok means all of these. It means fear, it means love, it means hate, proper hate. For the Martian map, you cannot hate anything unless you grok it. Understand it so thoroughly that you merge with it and it merges with you. Then you can hate it by hating yourself. But this implies that you love it too and cherish it I would not want to have it otherwise. It's a great book. So this key part of it, though, this understand it so thoroughly that it merges with you and you merge with it. This is what the programming community sort of like took in. And there is like this file in the programming community that's been around probably since the 70s or 80s called the Jargon File. It was actually published in print under the name The Hacker Dictionary. And it was just like, it's basically a dictionary of weird like coding and hacking and computer terms. And they define grok as to understand. And then they say that it connotes intimate and exhaustive knowledge. When you can claim to grok some knowledge or technique, you are asserting that you have not merely learned it in a detached instrumental way, but that it has become part of you, and that should be a part of your identity. And so the reason I bring this up is that, like, when you are writing code, you're trying to deal with complexity, right? You're trying to sort of like, because every program has a whole bunch of complex parts to it. But not every programmer working with that code should be exposed to all of that complexity. You want to write in a way where you can think about the next reader of your code, and you want them to be able to grok your code. You want it to be so that they can like understand your code so thoroughly that they just understand it like deep within themselves. And then they can like both love it and hate it in that deep kind of way. But that also means that they can modify it, right? Because that's what you want to give other programmers the tools to be able to do, right? Because you are usually going to be working on a team. And so the code that you write needs to be grokkable by your teammates or just by yourself in 6 months' time, right? Because you are your own teammate sometimes, right? And so in 6 months' time, will you be able to grok your own code? Will you understand it so thoroughly that you can just modify it without turning it into a ball of mud? So that's why I bring up the term grok. I just think that trying to take it back from Elon Musk, because I'm very upset that he stole that word. But yes, low complexity leads to grokkable code, and we should always be writing our code for the next reader, even when that next reader is ourself. So to revisit the 3 C's, high cohesion, easy to name a thing. It changes for one reason and usually one reason only. Low coupling, smaller ripple counts across files and functions, and low complexity, clearer, more readable, grokkable code. I'm going to give us a little bit of a break, and then we will look at some really bad looking code, and we'll talk about some heuristics for that code. I will just leave you with these 3 questions. When you're looking at your own code or that of others, you can ask yourself these 3 questions as a way of like thinking about the 3 C's. Does this unit have one purpose? That's going to give you that gauge of like, are you reaching that state of high cohesion? If I change this, what else needs to change? That's you looking for low coupling. And can a new reader easily follow this logic? That's our goal for low complexity. And you can never get rid of the complexity. You can just hide it away behind abstractions. And then if someone needs to get into that, they can, but you're shielding them from it, you know, in the day-to-day part of the, you know, working with the code. All right, let's take a 15-minute break. We'll start back up at 2:10, and we will interrogate some really awful code. And then we will talk about some other heuristics beyond just coupling and cohesion that will give us a way to identify code smells. I'm going to post into into Teams. We have a Teams that we have never used before, which is associated with this software development course. And I'm posting into it 2 things. 1, a link to some poorly written code. And 2, a link to the slides if you want the direct link before I post it to Teams. And I would ask you just pull up the code. and just like take a moment to look through this code and try to identify some reasons why this code might not be of the highest quality. And just sort of go with like gut feel. You don't need to go into like the nitty gritty of like what's, like the, line by line implementation details, because I'm not even really saying what this code is for. I had a large language model generate this code. I figured that might be a good use of AI, is to generate bad code. Yeah.
Why are all of the, I don't know what any of these variables do.
I'm gonna cry.
Yeah, you don't know what that's a thing.
They play maths, like what?
Huh?
What else do you see in this code that might be?
143.
Oh, great.
Why is it one line?
N8 plants.
Yeah.
Constant flux. I mean,
What the hell is that? It's all nested with one another.
What is this indents?
That's what I want to cry about.
I'm looking.
Okay,
at
so
the
like,
mountain.
just looking at this code, you have a gut feel of what? Would you want to work with this code?
I'm finding when you
this
first
person's doing drawings with their indentation.
Yes.
What the frick?
Okay, so again, this is like I asked an AI to generate purposefully bad code.
Can you tell it to fix it?
I mean, probably.
We'll see
Uh,
I want to what it does.
But
What does this even do?
this is Minesweeper.
Oh. What?
Oh, I see it. Flag reveal. Reveal.
See, there's flags, there's reveal,
Peak.
there's the state. So there's like but the only way of really knowing some things is like there's a very small number of comments. Without those 3 comments, it probably would have been
State of Thailand.
completely unknowable. And so just list off some of the smells that you identified in this code. I heard someone say, like, Jake, you were saying, like, I don't know what any of these variables do. Sadie.
A, there's no comments, and B, like, for one, I'm not the best at reading, like, a whole, like, one-liner, 4 loops.
Okay,
Like,
yeah. So, like, there's, like,
no comments.
there's, like, some density problems. There's no comments. Look at these, some of these lines here. This is actually a nested for loop right here. But in one line. Because look, it's a for loop that contains another for loop that contains an if.
A nested for loop in a one line. So if you scroll down to the bottom to the one method, it's like 100 lines of code for one method.
Okay, so that's a good one. The length of this method here.
It's impossible to know what functionality ends and what. Like it early returns like 20 lines in.
Yeah.
It doesn't.
It early returns here, it early returns here, it early returns here, and then it has like
That is the next part I wanted to talk about. The mountains.
look,
The mountains.
Was
The
upstairs.
flood of stairs. Right
yeah,
here.
look at that.
The stairs.
Okay, so like the indentation like is giving us some kind of like creepy feeling. It's like deeply nested with this beautiful stack of curly braces at the end, only to,
I'd be staring at the middle of my screen instead of the left.
and it's like it's got
Else.
while loops.
For loops this nest is right there.
That's the nest is in an else.
There's you can see like deeply nested and almost at the furthest level of nesting, there is a for
There's
loop.
even more variables inside.
Yeah. So as you can see here, even though this is an exaggeratory, I have seen code that looks like this in my years as a programmer, as I said earlier, and it it does exist, but we have a gut feel, right? You can see this code, and there are like gut feels that we have. So I'm gonna put some names to some of those feelings. Yeah.
Did you promote this guy to manager?
Absolutely.
Did he want to be writing code anymore?
I mean, that is one way of removing someone from a software development position. So let's try to give some names to some of the gut feels that you maybe have, and these are going to be heuristics for, like, again, that was like an extreme case, but I want you to be able to, like, almost have, like, yeah, a little bit of heuristics around identifying, you know, what was accentuated there in the extreme, but even identifying that when it just starts to get out of hand. So we're going to look at code quality heuristics. Sometimes these are just known as like being able to identify smelly code or code smells. These are not like laws of programming, right? These are just like little indicators. And when one of these like heuristics trips in your brain, it should just be a sign that, like, oh, I should make a branch in this code and I should fix this problem, right? Before it gets out of hand. And the goal is that we're going to try to, as we're developing, spend some time making small, hopefully reversible changes that are affecting the structure only and not the behavior. You want to separate those two out. So sometimes when you go to add some functionality to some code, you'll get to a place where the code needs to be massaged a little bit before you can actually add that functionality. There's this idea of, like, make the change easy and then make the easy change, right? So you rework your code to, like, anticipate what needs to happen, but you don't want to mix those things up together, right? You don't want to be changing both structure and behavior at the same time. You want to, before you make the behavioral change, focus structurally only. And this works best if you can have some kind of automated test suite. Hard to do in games, right? Automated test suites for games is, like, you can automate some of your tests in games if you can, like, look at functions that are just input-output functions, like that do calculations for you. When given this bit of data, you're expecting that bit of data. There are other ways of doing automation in games where you could, like, literally have, like, a script that's sort of like pressing buttons at the right times and trying to get through a level. But some form of testing is great to have in place before you start messing around with structure, because you don't want to be, like, trying to fix up the code but actually breaking it in the process, right? And sometimes the testing is just us manually, right? We know the game fairly well, we know how to speedrun it or whatever, so we make a little change and then we make sure we can get through the game and or the level or whatnot, and then we continue on. The very first of these tests is the unit length threshold. And again, unit here can mean lots of different things, but you and your team should likely try to decide on some soft limits for how long a function or method should be, how long a class should be. I'm saying roughly here, my gut feeling is that, like, functions and methods, 25 to 30 lines of code max. We saw that 100-line method and we immediately said, like, this is doing too much, right? There's just, like, what is this? Why? Why is there so much code in this one thing? And then classes, like around 300 lines. And again, these are not rules. Sometimes you're going to have a really long method. Sometimes you're going to have a really big class. So these are not things that you're going to, like, wield as laws on your fellow developers and say, like, we can't have any method longer than this or whatnot, but they're just indicators, right? When I was more doing web programming, and I did a lot in a framework called Ruby on Rails, and this woman named Sandy Metz came up with, like, what her rules were, and her rules were extreme. And people tried working within them to various levels of success. But her rules for developers were: classes can be no longer than 100 lines of code, and methods can be no longer than 5 lines of code.
How much? Then you're cramming everything into those 5 lines and making even more.
Well, her argument is that those methods can call other methods, right? And so you're just creating well-named small units of functionality that make your code hopefully quite readable. Now again, I think she was, like, pushing this again to sort of take it to an extreme and sort of see what became of your code when you tried to code to these rules. And the first one is just These two are very specific just to Ruby on Rails, so I don't need to cover those.
Wouldn't it be like a lot of jumping around to see what other methods are doing?
I mean, and that is the problem. I mean, and we do have, like, you can control click things in most IDEs to follow through, but yeah, if you have a lot of really short methods, that can be problematic as well, right? Because you're constantly now chasing down behavior. So every set of rules has its ups and downsides. I would never recommend, especially in game development, going to this extreme. In a web framework, it actually wasn't that bad. I tried coding to these standards for a while. Yeah, and you can do it, and it doesn't end up, you don't end up with that bad of code. But again, with web development, you're going to a database, you're fetching some stuff, and you're throwing it up in HTML. Like, you're not building a giant, responsive game system. So I think, like, the limits that I have here are probably a little bit closer to what you're going to try to aim for. So 20 to 25 lines for our methods, 300 lines for our classes. The test is if you just find yourself scrolling a lot, right? That's just like if you're your middle mouse scroll, you're doing that a lot. It's probably the unit of code you're working with is probably too big, right? And it'll just be helpful to break it up. And so the red flags are really long methods, really long classes, and that usually means they've got mixed concerns, and that usually means low cohesion, right? That they're doing too many things. If we went and looked at that one long method that was in our Minesweeper class, it was probably doing a lot. And so that one method probably had really low cohesion. All right, that's the first of our little heuristics. The next one is what some people call arrow code or the pyramid of doom. That's the nesting, right? That's this. If I zoom out, what some people will do is they'll talk about what they call the squint test, where you literally just like squint at your code, or like in some IDEs you got like the little mini map of the code that sort of shows you just the shape of it, or you just do this and you zoom way out and then you look at it, and like we can just see that that's bad code without looking at the contents of the code alone, because we just see lots of jagged, right? When you see sort of like a big long set of stairs like this, or you just see really deep nesting, and this isn't even as bad as it actually would be, because here the indents are only 2 spaces, right? So if we were doing something like 4 spaces, which is a little bit more common, these would be even further over to the right. So like, yeah, this is definitely like a pyramid of doom kind of shape, 2 of them going on in the code. So a squint test is often a good indicator, and you'll just see that, right? You'll start writing your code and you'll realize that you are developing more horizontally than you are like vertically, and then you want to be developing more vertically than horizontally. The other thing that can like force us overly horizontal is like method chaining. When you have like this method dot this method dot that method dot that method, and it can sometimes feel nice to do a big long method chain that does something, but that becomes very unreadable, and it breaks what's called Demeter's law, which is like, don't method chain, because that means you know a lot about the insides of the things that are being returned to you. So that's the second one, the squint one. Red flags, many nested if-else's, loops, catches. There is a whole way of actually analyzing what's called cyclomatic complexity, right? Because I think I heard someone, we were seeing this here, is like someone like saying maybe we could count how many if statements and loops there were here. The idea of cyclomatic complexity is like how many possible paths are there through our code. And again, remember, all these rules are to help the poor human brain, because the computer can go through every single possible path and it doesn't break a sweat. But we can only hold so much complexity inside of our minds, right? And so there are tools that will measure cyclomatic complexity for us. So that code was written in JavaScript, and so I can go to what's called jshint.com, and you can paste JavaScript in here, and it will do things like it'll analyze, and it'll show you like how many arguments the methods have, like how many statements there are, and it'll measure what's the cyclomatic complexity of the methods in your code. And so if I take this crazy code here, go to the raw, and I will copy and paste it into JS hint. And then I gotta grab this little,
67.
the warnings are just that it doesn't know that it's ES6, so I put that in and they go away. That's just a little hint there for the linter here. So there are 8 functions in this code. Function with the largest signature takes 4 arguments. That's another code smell when you start to have like method or function signatures that have like more and more and more parameters on them. That probably indicates low cohesion, because like, why do you need that many parameters?
Well, at least you need, like, I think you, to instantiate an object, you at least need 2, and then
Yeah.
you go to 3, 4, 5.
Yeah, but like beyond that, you're probably,
Just like around 4, 3.
yeah, 4. I think 3 to 5 might be like a good target.
Or otherwise put like a past a class.
Yes, otherwise it probably means that there's like some abstraction that you're missing, right? Like one of the things I noticed when I was developing Minesweeper is that like I had a whole bunch of methods that part of their parameters was an X and a Y. I'm like, oh, I need like an X and Y struct that I can pass these things around together. So it's usually an indication that like you're missing a concept in your code.
Okay.
Yeah.
Is a good way to get around that to use like overflows where you have like base, like you have the parameters are set by default and then you only run the ones that you need to run?
You can, but then you still have a lot of parameters, right? So you're not you're sort of like almost like hiding the fact that you have so many parameters. Like one of the things that I was doing with these rules here, because they also have parameter limits, pass no more than 4 parameters into a method, is I found myself trying to get around this by passing like a hash map that contained a bunch of key value pairs inside of it. But that was just a way of me like hiding extra parameters, and it felt like, oh, I'm just passing in one thing, but really I'm passing in a bunch of key value pairs of things that might as well have been parameters and probably should have been, and now the compiler can't even check them for type safety. So like trying to get around the rules was probably not a good idea there either. And then you can see here, it's counting it says like the largest function has 110 statements in it. The median is 10. So that's like a real good indicator that this act method is, in need of help. And this does the cyclomatic complexity. The idea is that when your cyclomatic complexity is greater than 10, you're probably in need of like refactoring that code, and that method is at 66. So that's like, it needs some major work. And like cyclomatic complexity, it's not just as simple as actually like how many paths there are in the code. But it's like you basically are treating your code as if it is a sort of a graph. And then the formula is this one here. Number of edges, number of nodes. So the edges are the lines, the nodes are the pieces of code that are executed after the lines, and then the number of connected components. And that's the one I don't really ever fully grok when it comes to cyclomatic complexity. But yeah, it is a measurable factor. And at some companies, what they will do is they will have linting algorithms like this that are part of the commit hook. And so when you commit code to like your main repository, before you can go through a pull request, the code's going to go through an analysis, and it's going to be like your pull request is going to be like auto denied if some of the hinting rules are not met. Right? So I don't know how common that is in game development, but in web development it was quite a common thing. And they would usually be pretty forgiving. Like your code would have to go to a fairly extreme length to like fail those tests. But yeah, it's sort of a good thing. You go to submit something and you just get an indication like, yeah, this code's probably going to be pretty hard to read because your cyclomatic complexity is 66. Don't do that, right? So yeah, so you can sometimes have sort of like automated processes that will do some analysis on your code.
For state machines, right? there could be a bunch of possibilities, even like when you're using the Unity animator, like there's like probably like at least you can have 100 just because you can have a little line.
Yes.
Can you simplify that down too, or?
State machines are almost like you almost can't because you need all those states, right?
Yeah.
And you need all the transitions. And so they're going to just be inherently complex. And that's why Unity gives you like the visualized form of them, because dealing with a state machine in code is really cognitively hard, but dealing with a state machine visually makes a lot of sense.
Okay.
And so sometimes that, like, I imagine that that's just why they added that to Unity. And the same exists in Unreal. You have that same kind of animation blueprint state machine as a visual thing, because again, having complex code is not really a problem for the computer, but you need some way for the human to be able to deal with that code. And so visualizing it as a visual state machine where you can look at the transitions and you look at the different states, then you've almost removed the complexity by way of a visualization tool.
Okay, so you can ignore this rule if you're doing
Yeah, yeah, definitely, because they've put something in place to help the human deal with. Because if you looked at my Unity state machine just in code, I imagine it would just be ungrokkable, right? You'd just be like all these Boolean flags, and there would be switch statements, and you couldn't make heads or tails of it. And you're going to have to do that in your final applied math assignment. Because I'm going to make you by hand do a little bit of a platformer. And like, if you think about a platformer, there's going to be state management, right? The person's going to be in the air, they might be falling, they might be jumping, they might be on the surface. So like some state management is going to be necessary, and your brains are going to be taxed by that. But then it'll just make you appreciate the game engine so much more at the end of the day, right? I'm doing this for your own good. The one sentence rule, which is literally like, can you describe this thing in one sentence? Like, is the function, the method, the class, can you, like, you bring someone over and you're like, this thing does this. And if you find yourself needing grammatical conjunctions, like if you need an and, or a then, or an or an also, like that again is an indication of low cohesion, because it's probably doing many different things. Another flag for this, red flag, is like if you have a method that has a Boolean parameter, that's usually an indication that the method is doing two things. The method does one thing when this Boolean parameter is true, the method does another thing when the Boolean parameter is false. That is just straight up a low, like there's low cohesion on that method. And you could probably just make two methods that do those two separate things and give them good names, right? So like instead of having like a render method where there's like a true false in it that means like show the thing or hide the thing, like have a show method and a hide method. And then you've made the system more understandable by the human reading it, rather than having to like parse out, okay, this is a render method, this thing's set to true, true means show or true means false. Well, I gotta go read the docs or whatever. So yeah, if you've got a Boolean flag in your parameter list, it's usually an indication that you're doing too much in that method. Other red flags are just like utility buckets, like a class or a file just becomes a dumping ground for like utility or helper files or helper classes or helper methods. I do this all the time. I often have like a file that's just called helpers. It's not the end of the world, but after a while you might find that you could start grouping some of those helpers together. Maybe some of those helpers are related to this kind of task and these helpers are related to another kind of task. And by splitting them out, you can get a little bit more cohesion. You could name the file something better than just helpers. These might be render helpers. These might be math helpers. These might be etc. So again, these are not like, it's not like you've done something bad if you have a utilities class or a utilities file, but it just could be an indication that there could be some refactoring that needs to happen there.
In my previous project, I had a very massive utility class. And
It happens, right?
Yeah. And the funniest part was, because it was in Unity, I was only accessing it through namespace. So everything was accessed to namespace. It was called namespace Jeff. Yeah. So the most helpful utility class in that entire project.
And you've just got the word Jeff like just scattered throughout your code. Yeah, that's absolutely lovely. And what Where did the name come from?
I just needed a name for the utility.
And you probably weren't expecting it to be as heavily used as it became.
Yeah.
But that's where like auto like refactoring tools, like you could go into Visual Studio and you could just like right click and say rename, and it'll just rename that everywhere for you. Beautiful. 3 strikes rule for repetition. Sometimes programmers are a little bit too eager to try to dry up their code, and like dry as in the acronym for don't repeat yourself, right? So like we see something and we're like, oh, this is like, maybe I could turn this into, you know, a method or a function or a class because I don't want to repeat myself. But you usually want to wait for like the 3rd time. The first time you see the repetition, you're okay. Maybe do a little bit of copy pasting. Again, back to Sandy Metz, who came up with these 3 rules. She often says like that a little bit of repetition is better than the wrong abstraction, right? If you only see this thing repeated twice, you maybe don't know enough about how to make a genericized version of that repeated code. 3 times and it's all the same and all 3 times, okay, maybe fair. You can start to maybe try to figure out a generic pattern to replace that. Again, when I was developing my version of Minesweeper, in a lot of cases, Minesweeper, you're working on a grid, and there's a lot of times where you have to process the tiles that are neighboring a particular tile. Sort of like, did you all do Game of Life in any classes here yet? No, Dylan sometimes gets you to do Game of Life.
Yeah.
Later? Okay, so that will also have this idea of like, you're in a grid of cells and you have to think about like, who are the neighbors of the cell? And there's like 8 neighbors, right? And I found myself in the Minesweeper project doing this pattern where I had a nested for loop, and inside of it, the top for loop was like x from -1 to 1. The inner loop was y from -1 to 1. And right inside, I'm skipping or like continuing the loop anytime where x and y are 0, meaning that's the tile itself. So when you go through that, you're basically visiting all 8 neighbors. And like the 3rd or 4th time I saw that crop up in my code, I'm like, okay, I need an abstraction here that I can call like for all neighbors, and I can just pass it like a thing to do for all the neighbors, right? But I waited long enough that I could see it done in a number of places, and I'm like, I felt confident enough being like, okay, I can generalize this now. I can make my for all neighbors. I've seen it used in various places, and then the next time it cropped up, yeah, it worked. I had my for all neighbors, it was ready to go, and I had seen enough examples of it that it was generalized correctly that I could just use it and make use of it. So don't be too quick to remove repeated code, even if you have to copy and paste a little bit, but eventually it's probably a good idea if you see the same logic cropping up over and over, and 3 strikes is usually, that's the rule of thumb. That's like, I had an engineering manager that was like, he banned us. Because like we're a bunch of like nerdy engineers, we're always trying to over-optimize our code. He's like, you're not allowed to create abstractions or generalizations in your code unless it's like the 3rd time you've had to like manually copy paste something. Like, okay, it's not as fun that way. So yeah, and again, the red flags are like you're literally copying pasting code from one area to another, and sometimes this will lead to coupling. Right? Because like you've copied and pasted the code 3 times and you realize it's wrong. Now you need to change it in 3 places, right? So every time you copy paste, you are potentially coupling code, which is why if you do it too many times, you should try to refactor that. This we were just talking about, this idea of like a long parameter list. And here I said rule of thumb is like you're greater than 4, you're probably verging on too many parameters. I will allow myself to have constructors that have more, because sometimes an object has a lot of state that it needs to construct. But like 5, 6, you're in danger territory. If you're up at 8 to 10 parameters for a method or a constructor, like there's something wrong there. Like there's too much data going in here. But it also, again, could just be the fact that you're missing a concept in your code. You're missing a class, you're missing something that needs to like gather this data up, and then you could like reduce it to a new named thing and pass that around instead. So again, the test here is it's hard to call a thing without like looking up the order of the args. This has become less and less of a test because now our IDEs, we just hover over the thing and it tells us what the arguments are. But then when you do that hover over and you see a list of like a bunch of arguments, again, that's like the red flag. This one I've already talked to you about, but I always will bring it up again. We talk about this in applied math, but like magic numbers. Right? Anytime you have bare literals, usually numbers in your code that have no explanation, maybe other than the name of the variable that they're being placed into or the expression that they're part of, it's usually a bad sign, right? And like, if that number changed, do you even know what the ramifications are of that change? Maybe you do, because you're deeply, sort of intimately involved with the code. But if someone else is coming to your code and they look at that number, one, do they know what it is? And two, do they know what actually is going to occur if that number gets changed? Dead code. I see this with students all the time. I do this myself. Like, you've got some code, it's no longer really part of your project, it's not needed anymore, and like students will like leave it in there but comment it out, just in case they might need it later on, or maybe they're really proud of it. They're like, this was great code, I just can't bring myself to delete this code. Who has done this? Who is like, yes, like I do this all the time. We have source control, right? Just the source control will remember your beautiful code, and it will be in source control just in case you need it.
None of processing butter.
What's that?
None of processing.
Oh, that's right. In P5, yes. So at the beginning of next term, we're going to move into P5 locally with an IDE and source control, and you won't need to have blocks of code commented out anymore. But yes, this is a big one. That's why I made really big text for it, because I've seen this like everywhere. Like all the legacy code I worked on as an engineer, I would be constantly coming across giant blocks of code that were just like sitting in the middle of a file and just like getting in my way. And like, why is this here? Maybe it's important. Like maybe this is here for a reason. Like I can't delete it. Someone left it here. And then I'd be like, I just feel like I should delete it. But then I'd be scared to. Or sometimes it's like not even like commented out. It's just code that like there's no way to get into that code anymore, right? It's like a dead path, like nothing, and you can't really tell just by looking at it. So now you're like putting in like logging statements and like running the program over and over and seeing if this code ever actually triggers. And yeah, it just, even that code, hopefully you can find some way of getting rid of it. Because dead code is not always commented out. It just might be dead in the fact that like nothing is pathing to that code anymore, or nothing is calling that method anymore, or nothing is using that class anymore.
I actually have a question relating to the sort of long parameters.
Yeah.
Would you say that constructors are like an exception to that, or? Okay.
Yeah, constructors are, but you still don't want like an 8 to 10 arg constructor. But like constructors often do have a lot of state, but is that an indication of like low cohesion? Like why do they need all of that state? So yeah, red flags here is just like that urge to keep code around just in case it might be needed in the future. And if we're using version control, then you just don't need to worry about that. It will be there. You just got to find the commit. The good old KISS principle, keep it simple, silly. As programmers, we sometimes like to be clever. Who likes to be clever in the room here? Anyone really like to be clever? I like to be clever. You should not be writing clever code, right? Like, because clever code is usually not very readable. And so I, for years, wrote overly clever code. And when I was working as an engineer, I had like the more senior engineers tell me over and over, like, Kyle, we know that you're clever, but you do not need to show us in your code. Like, no one is going to understand what the heck is going on here. Yes, you've made a beautiful one-liner, and we'll do a little round of applause for you right now. but we're gonna have you remove this from the code. And I got the lesson. I was like, okay, I see what you're saying, because then I started to read other people's code, and I would get to like little clever one-liners. I'd be like, I have no idea what this is doing. I think they were actually trolling me. I think they were like then putting in one-liners to code that I had to work on so that I would feel their pain. I just realized that just now in the moment. Wow, that was good of them, because I learned my lesson. Yes.
So when you say one-liners, you've been telling us in P5 to put our if commands all in one string.
Yeah, as long as, again, you want it to be readable, right?
But no one-liners.
Well, it's again, these are not rules. Like, they're not commands from up high. They're just like indications. Like if you write some code and you're like sitting there thinking like, oh, I'm so clever, then you're like, that code should probably not be there.
Would you say that like a good way to sort of counteract that is if you have like just a really solid one-liner that you like that isn't too complex,
Yeah.
but might be a little bit hard to glance at a glance. Would you just say put a comment about saying exactly what it does?
Yes, but also that urge to comment is often also a smell, right? Like why is like my code's probably not that self-documenting if I need to do this, but there is some aspect of like socializing idea in the team, right? If you've come up with a clever way to do something that actually like benefits the code in that like it's extra performant or it just like saves a lot of extra complexity elsewhere, you can just socialize that idea in the team. You can do a code review with everybody and say like, look, I found this cool thing. It makes the code way shorter. It's not easy to understand at first. It's like ternary statements, right? Some people will tell you don't use them at all, but you can also just like socialize on the team like how to read them. And then once everybody knows how to read them, as long as you're not doing deeply nested ones, it's fine.
I know Link, like for like database access.
Yeah, I love Link.
That's like a good thing to use.
Yes.
But
It also feels a little clever at times.
yeah, the whole it's like a bunch of anonymous functions, and you can get 5 groups, and then you go into another function.
Yeah.
Then into another one if you wanted to.
Yes. But it also is like, if you write Link well, it is quite readable, right? You can
Yeah.
sort of chain things together and you're sorting and you're filtering, and like if the other person knows Link, then
It's okay.
it's okay. Yeah, so again, that's another one of those things where you would like, we used to do lunch and learns at work, where it's like you learned a new thing and you sort of like, you get a bunch of the other engineers in the room at lunchtime and you like teach them a thing, and then you've socialized that idea to the team, and then it's not like overly clever because now everybody knows how to do it. So again, dense one-liners, potential red flags, nested ternaries, over general abstractions. Yeah, if it feels too clever, it's probably too clever, and just write it out in a clearer way. We did it. We've identified all the smells. Did I miss any? Is there any other things that you like when you're looking over code, even your own code? Is there something that like reaches out to you and you sort of know that you've done something wrong? You're like, this feels a little bit dirty or off or bad. Yeah.
Not sure if it fits here exactly. There's like the bits of some projects where there's some random JPEG or file that seems absolutely useless, but if you remove it, it breaks.
Yes. Yeah, and it's probably not commented anywhere or explained anywhere.
I think like there's like I think there's some valve data or I think I've heard for yeah TF2 that they have some random JPEG that like
That if you remove it from the game.
breaks the game right there.
Yeah. And you know, programmers are known to do those kind of things. There is in Unreal like the default texture that exists when there's no texture in place is like a picture. It looks like mold, like it's just this green, ugly, moldy thing. And like every once in a while, I'll look over at artist screen and I'll see this like gross mold. And then I heard like Tim Sweeney, like the CEO of Epic talk, and he's like, yeah, I added that like way back in like Epic 1, like Unreal 1, just thinking I was going to have a placeholder in because I didn't have a texture. And he's like, I've never been able to get that out of the code base ever since. And so yes, absolutely. Any other thoughts of like things that while you're actually writing your code, like what we used to call them at work was like kludges. And like a kludge is like a not so satisfying fix to a problem you're having. Like it gets the job done, you've like fixed the bug or you've added the feature, but it's a kludge. Like, it just feels dirty, but like you didn't have time to do it any other way.
I mean, it kind of just, not necessarily related to that, but what I've found recently that I find it very fun if I'm going through and writing a method and then I realize, oh shit, all of it is in one if statement, what the entire thing, just take the if statement out and just put an early return at the beginning. It makes it so much cleaner and easier.
Yeah, you've gotten rid of one level of nesting, and like, yeah, your code has like a guard class at the beginning of it, so it's much more readable because you sort of know the exit's path up front.
Oh yeah, I really like putting it just at the front of the code, just a long like list of dashes in a comment saying requirement checks, and then listing what all the requirements are.
Yeah, and I think that is like in the tidy first book. I think that is like the first tidying is like the use guard clauses rather than nesting. Any other things that you've seen in your code that have sort of made you sort of like a little bit embarrassed about your like wanting to show it to other people? Yeah.
Well, this was actually kind of recently, but doing a timer function, I spent a whole night on it because I needed to use it twice.
Okay.
And each one had a different parameter passed through, and my function was not working because it's not in the update function. So the way I was implementing it, it wasn't updating it in the data or the data time. It was updating it while it like.
Okay.
So I was just done with it. I chucked it in 2 separate if statements, and I'm
Yeah.
not proud of it, but it worked.
And I mean, that's a kludge, right? It worked. It did the job done. Not necessarily proud of it, but it's not horrible either, right? But then like someone else comes to that code and they're gonna wonder like why, and they're gonna maybe wonder like, is maybe Sadie had a really good reason for doing this, and like, yeah,
I just couldn't figure it out.
Yeah.
I spent all night on it.
and that's fair. Yeah.
I would say I'll say I refactor it later, and then I leave it 10 years later.
I know. I mean, I've tried to ban myself from leaving like to-do messages to myself in my code because like they never get actually done. I do know companies that have like to-do searching hooks for like pre-commit hooks. So, like when you commit and like if there's like a to-do in there, it like kicks it back to you and like it looks like you still have some work to do. So yeah. Anyways, I think that's where we will end things. I hope you enjoyed this sort of look at code quality. Again, these are not hard, fast rules. They're just heuristics that you can use. Don't wield them as weapons on each other in like group projects. Kyle said that we could only have this and that. No, they're just heuristics, right? And there's always, for every rule, there is a reason to break that rule, right? So always be open to the fact that we might need to break all of these rules for some reason when we are coding. Especially in game development where like, if you talk to game devs, they will tell you that their code is like a series of kludges and like, you know, like packing tape and it's just like, it happens, right? And then it gets shipped and then that's that.
But how can you ship something like that and then work on it later?
I mean, that is the big problem, right?
Because I imagine No Man's Sky wasn't held up by glue, duct tape, popsicle sticks, because they redeveloped the game over, I don't know, 7 years, 8 years.
Yeah, but I imagine some of that redevelopment was refactoring.
Yeah, I think they did something that was so you can module, or like you can build your own chip now.
Okay, yeah, I'm sure they did some cleanup refactoring along the way to like remove the nasty bits that may have shipped.
Yeah, I think Minecraft too. Every time they do an update, they rewrite them completely.
I mean,
I've heard.
yeah, it's a possibility.